All right, guys, today is the day 4 polar homework key, just talking through some of the equations here. So again, as always, feel free to fast forward through to any of the problems that you need if you struggled with any of them in particular. And as always, please sign up for Google Meet if you need it, or email me or message me with any questions on any of them in particular. Don't be afraid to do that. So the first one here is one of our newest graphs, the lemniscates here. Looking at these, again, we knew that because it had the r squared on that. Again, looking at these, again, the r squared, we have to keep in mind r squared always has to be a positive number. So that means this part over here on the right always has to be a positive here, okay? So we also know, just by looking at some of the patterns, that the farthest distance away from the pole is going to have to be 2 on there. Again, another way to think about it, we know the biggest value that a cosine can ever equal is positive 1. Smallest number is negative 1. So it's between negative 1 and positive 1. So if this were positive 1, 4 times positive 1 would be 4. We would take the square root of it. Again, that distance would be 2. If it were negative 1, 4 times negative 1 would be negative 4. We would not have r squared. That would be able to be equal to negative 4. So that's why we can think about, all right, that we want this value here to be positive 1, because that's going to tell us when it's at its furthest points away from the pole there. So we can do that. We can say, all right, where is the cosine of 2 theta equal to 1? Again, since we're at the 2 theta, really the interval for all of those, if it's a 2 theta, are always going to be between 0 and 4 pi not included. So we want to think, okay, that means 2 theta. We want to know where is the cosine equal to 1. We know the cosine is equal to 1 at 0, and it's also then equal to 1 at 2 pi in this interval. Again, we're not going to include 4 pi because it doesn't have the equal to on that. So 2 theta is equal to both of those. We divide by 2. That means theta is 0 and pi. Again, I wrote just a little note. That's when the r value, if you were to put that in and if you were to take like the square root, that's when the r value is really equal to positive or negative 2 essentially. So at 0, if it's positive 2, it would be right here. At 0, negative 2 would be over here on the left-hand side. If we're at pi, again, here that r value would be positive 2 right on the left, and r value would be negative 2 on the right. So essentially, again, it just completes those 2 petals there because they would just mirror each other. All right, looking at number 2. Again, that's why it's important to kind of practice all of these, because this is not one of our new graphs. This is one we learned a few days ago. This one is a rose. This one in particular is a rose with 3 petals. Again, when that number in here is odd, that's the number of petals that we're going to have, because again, it actually ends up just repeating itself over. You'll notice I actually showed 2 different ways to do this. In the video, this was the main way. I had gone through it in the notes and on my other homework. I thought I'd put this because I did see, as I was kind of going through some of the homework, a few people were doing it this way as well, because I mentioned it in the notes and kind of showed it in a little bit of my explanation. I don't care which way you do it. You could absolutely do it both ways. The reason I had started doing it this way is because for all the other ones, we had started to find out, started by finding out where is r equal to 0, where does the graph intersect the pole. But you also could do it this way, where is r positive 6 and negative 6, because we know that it is going to be 6 units away from the pole is our furthest distance away. So you could have done it that way as well. Again, that's actually ends up being kind of similar to how we did the lemniscates over here. So you could have done it that way too. So I included that method as well, just to show you that really you could do either. So if you go through the original way we had thought about it, where is the sine equal to 0? We know that's at 0 and pi, but again, we're now going between 0 and 6 pi, so we had to find all the coterminal angles. Pretty easy to do on this particular one. Then we divide by 3. But these are not where our petals are. That's what's important. This is not where our petals actually are. This is like where it hits 0. So if you remember, because it's symmetric, our petals are really halfway between. So if we have 0 right here, let me draw it in here. I'll pick green. If we're here at Oh, okay, or purple. If we're here at 0, and then pi over 3 is right here, go away. All right, pi over 3 is right here. Halfway between would be right here at pi over 6. But if you were to plug in pi over 6, 3 times pi over 6 would give you pi over 2. And we know that the sign of pi over 2 is 1, but 1 times negative 6 would be negative 6. So that actually corresponds to this blue point over here on the left-hand side here, down here. Because again, positive would be in this direction, negative over here. If I'm between pi over 3 and 2 pi over 3, so again, thinking about these values right here, halfway between is pi over 2. 3 times pi over 2 is 3 pi over 2. So we know that the sign of 3 pi over 2 is negative 1. So negative 1 times negative 6 would bring us to positive 6, or this orange point right here. Then halfway between 2 pi over 3 and pi is we've got 5 pi over 6 right here. So again, if I put in 5 pi over 6, 3 times 5 pi over 6 would be 5 pi over 2, or again, really that's 2.5 pi, or pi over 2 if we're thinking coterminal. And again, we know that the sign of pi over 2 or 5 pi over 2 is 1. Negative 6 times 1 is negative 6. That's why here's positive 5 pi over 6. Negative, our values would be over in this direction at that purple point. Again, that's one option for you. That's the way we had kind of talked through it originally. Now you do have the second option. Again, I don't care which way you do it, whichever way is easier for you. We can also decide again that we know that our furthest points away from the pole are either positive 6 or negative 6. So if I set the negative 6 sine of 3 theta equal to both positive 6 and negative 6, we really want to know where is the sine of 3 theta, positive 1 or negative 1. That's what we're thinking about there. So that means, again, we go through our whole process with the 3 theta and divide. We're still on the interval from 0 to 6 pi, so that's why I have the other numbers in there. And what this tells us then, at pi over 2, 7 pi over 6, and 11 pi over 6, that our value, the distance from the pole, is positive 6. So notice at pi over 2, it's that end of the petal. At 7 pi over 6, it's the end of the petal. And at 11 pi over 6, it's that positive end of the petal. All of these numbers are going to be where it equals negative 6 right there. That looks kind of sloppy on that. But at pi over 6, it's negative 6 right here. And then where else are we? 5 pi over 6, it's negative 6. And then 3 pi over 2, it's negative 6. I should make that look a little bit better of a negative there. Okay, so you have a couple different options. Again, I'll sometimes just pick one way to show, but I don't really care, whichever way work you want to show with that. All right, number 3 is one of our newer ones. This is another lemniscate, but this one is a sine. So same idea. And there's a negative right here, though, so that's another thing to think about. Again, here r squared still can only be positive. So that means if we have a negative number here, if this is a negative, the negative times the negative would make it a positive. So the sine of 2 theta always has to be a negative number. That's why this doesn't end up looking like the roses that we had before with that, because it had the r squared in it. Because of that exact idea right there, because we won't have all of our values in there. So that's just something to think about. Like from 0 to pi over 2, those values are not going to be included in there because that's where our sine of 2 theta would be positive. Okay, I'm rambling. So here we've got solved it again, still on the interval from 0 to 4 pi, like always with the 2 theta there. And so we get that 3 pi over 2 and 3 pi over 4 and 7 pi over 4 are the places where it's furthest away from the pole, both positive and negative 4, and we get our lemniscate there, kind of the figure 8. Number 4, I knew that this was a different one. We know that it's going to be one of our limesons here, okay, because again it had that a value and it had that k value here, so we know it's a limeson. So I set r equal to 0 to find out how many times it intersects the pole. So when I did that, I found that it only intersected the pole once, which told me that it was a cardioid. Okay, so we knew it was a cardioid. Then we can just start finding some values here. Find the values for theta, substitute them in, and we get our r values there. Now I picked pi over 6 and 5 pi over 6 because I knew those were the places where the sign is 1/2, and I thought that was a nice easy one to find there. So again, if the sign was 1/2, -2 times 1/2 would be -1, -2, that's where I got the -3s from. That helps us round out the curve of the cardioid. Looking at number 5 here, we knew that this one is a rose, again, because it's the not an R squared, so it's not one of our newer ones, the lemniscates there. We know this one's a rose because it had the A value and it had a B value. Again, the more you practice these, the more you're going to be able to recognize that. So if there's a 2 theta here, we know it has 4 petals. It's double on there. So again, I did it both ways on here. I set it equal to 0, and we find out the kind of middle parts of it right there. Again, those are not where the petals are. That's where it crosses through the pole. But again, we know that if it crosses through at pi over 4 and like 3 pi over 4, for example, it has to have a petal halfway between at pi over 2. So that's how I came up with those 4 petals. Again, if it's easier for you, you can notice that, okay, that we know this is a rose with 4 petals and that the biggest distance away from the pole is 6, because again, the biggest value for the cosine would be 1 right here. But again, cosine here could be -1. We don't have an R squared here. It could be negative. So we really want to find out where is that R value positive and -6? Those would be the furthest away from the pole values. So we found both of them. And again, notice you do have to do both of them on this one because here at 0 and at pi over 2, we know it is the positive, and then at pi over 2 and 3 pi over 2, sorry guys, I paused it because I noticed a mistake as I'm talking through it. This should be, and I'll fix it on the PDF, 2 pi, and this then should be at pi. As I was reading through my answer, my graph is completely correct, but as I'm reading through my answer, I realized that should not be a pi on that one. So at 0 and pi, it is a distance of 6, and then at pi over 2 and 3 pi over 2, it's -6. Sorry about that, guys. That's why I paused it for a second. It might have sounded a little weird if you were listening to it, but I just noticed a mistake that I had written on there. Okay. So anyways, the graph itself is exactly right. These were the ones that corresponded color-wise down here. I had just written down the wrong number over here. All right, so we've got another one of our lemniscates here because we know it had that R squared. Cosine of 2 theta has to equal -1 because a negative times a negative is the only way we're going to get the positive here. So we get at pi over 2 and 3 pi over 2 are where our 2 kind of petals are going to end up there. And again, they are a distance of 4 away from the pole. Number 7, we know this one is a circle. I'm noticing a number of people don't need to do a ton of work for these, which again is okay. Some of the work we did in our heads. Keep in mind though, if we when we do take an assessment on this, I do want to see some of your points on there, just so I know you know where you're getting those points from. But otherwise, this one shouldn't be too bad. We know it's cosine, so we know it's symmetric to the horizontal axis. Since it's negative, it's going to be going to the left, and we know it's a circle. Again, you'll notice I found the pi over 3 points. I did pi over 3 and 5 pi over 3. Those got the -2 values right there. If you did 2 pi over 3 and 4 pi over 3, you would have gotten +2 as your value, which is fine as well. So again, that just kind of helps us round out that curve. Last one is another lemniscate. Again, it has that R squared. You know it's a distance of 5 away from the pole there. And again, this has to be, sine of 2 theta has to be +1. So we go through and we find out that it's at pi over 4 and 5 pi over 4. And again, that's how we know where our 2 petals are. Let me know if there's questions. And again, we will hopefully connect again and see how you're doing on these. All right, good luck. Bye.